Hello and welcome back to the development of the Feersum scheme compiler. So in the last stream we went over adding support for references to external assemblies to our compiler. The place where we started there was, well, we started in the compile, like where we were actually ending up emitting things. So down in emit, we, as well as taking the route that we need to emit, we now also take Reflebs. So Reflebs is a collection that tells us about all of the library references. Then that allowed us to work out the external symbols and the external library initializers, so that when we compile down references to fields from other libraries, we were able to correctly import references and we were able to initialize libraries. And this is all driven by a change to the options, where we now have this references string list in our compilation options, and in the program itself we have a new command line switch, reference, which you can specify multiple of, and when we just collect those all together and pass that through as references. Then down in compile again, right at the root, we do a little bit of work to walk through all of the references. So what we do is we call this load referenced signatures, which is part of the built-ins, and it works a bit like load core signatures, except for the fact that it's using monosessil's reflection to walk through a library. It's loaded into the in via monosessil, and the load core signatures is using standard reflection over a direct assembly reference. But at the end of the day, what we end up with is these library signature instances, which tell you the name of the library and all of the things that are exported from the library. And with those references, we then add them to our core libraries, and then we are able to bind and emit successfully. So that means that we were able to define a new we define this file, import test, which calls import test greeter, greet twitch, and then when we compiled it with .NET run our compiler with -r spec bin lib greet, when we run our compiler with the -r to specify the reference, everything compiles okay, and then we can .NET spec bin import test. And this is then the import test assembly, which has an assembly reference to libgreet and is calling the greet function from there. So that all works, but there's a few places during the development where we cut some corners. We don't properly store library names for all of the code that we compile, because I struggled with getting the monosessil custom attribute arguments to serialize properly. And there's probably code duplication between the built-ins and how they're resolved and how our libraries are resolved. And then there's no actual like tests for this. So it would be nice if that import test could be moved into the specs folder and we could have our unit tests or integration tests actually compile that as well. So let's start by taking a look at the attribute. So there's this Lisp library attribute, and this is used in both the built-ins and the code that we emit to mark up code that mark up the library name. So when we use it in the built-ins, we're using this proper constructor where we're passing in a params array, which just makes it easier to use from C#, but really we're passing in an array of strings which represent the library name, because in Scheme, if we go to something like libs, this is an example of a library name. It's actually a list of identifiers, which we're treating as a list of strings. But our code actually emits calls to this constructor, where it's pasted all the identifiers together with a $. So the first thing I would like to do is get rid of this constructor. But to do that, we need to understand what's gone wrong. Well, what was going wrong with the way that we were serializing the arguments before. So this is the mono Cecil assembly reader file. This is the code that Mono uses to load assemblies. And every time it finds a custom attribute with constructor arguments, it uses this read custom attribute constructor arguments method to read them in. So what it does is it works out what the count is, allocates an array, and then loops calling read custom attribute fixed argument for that specific parameter. So we only had one parameter. Our parameter, though, was an array type. So we'd correctly tried to pass in a type with an array type. So we started off with a string and made it into an array type. But then that means we would have, when it was reading it and when it's also writing it, it goes down a code path where it's doing this read custom attribute fixed array argument. So read custom attribute fixed array argument, this is what we were seeing. We were seeing lots of Fs, and that's because it had been serialized as a null. And so what happens is, if you're reading an array type and the body is null, it gets serialized with this special token value. If the length is 0, then what we end up is actually a custom attribute argument with the array type containing an empty array of custom attribute arguments. And this is kind of the key here, that when we're dealing with array types, we can't just pass the string array in. We have to map the string array through into custom attribute argument instances. And this effectively, we would then end up going down this path where it's got multiple strings. It would call read custom attribute element on each one of them using the element type, which would be, if ours was a string array, it would be string. So let's go and start by trying to update our constructor call. What I'm going to do is get rid of that definition first. And then in the compiler, we have a function called mark with the library name. Yeah. And so what this is currently doing is getting the constructor, which is a type of string. So I'm going to change that to type of string array. And then it's adding a single argument, which is a custom attribute argument of type string, and then concatenating things. But what we want to do here is do type system string dot make array type to turn it into a string array. And then as a value, what we want to do is do, so this needs to be an actual .NET array at the end. But what we can do is do c dot map, and we will map so this is going to be like name part. So for every name part, we will create a new custom attribute argument, type.module.type system string name. Just going to copy and paste because this is the future. Can't be dealing with my own typing. So yeah, we want to make it, it's going to be a string, and then name part will be the value. So if we take the original name, map them into custom attribute arguments like that, and then do array of seek to turn it into a .NET array, we should end up with a custom attribute argument array as the value that we're passing in as the second part of the thing. And then that should mean that when we compile down libraries, we end up marking them up with an array of strings as their name. So I'm going to try running the test, which is going to build our compiler and then build all of our specs, and then we can inspect the IL, and hopefully we'll be passing strings in now. Spec bin qsort. So qsort is our quicksort spec library. So we have the library body. We're looking for the actual type declaration at the top. This is the lambdas, which are all the methods defined in the library. It's big. Here we go. So here's our type, qsort.sort. So this is our custom attribute, and it's an array of strings. And I don't see lots of F's in there anymore, which is good. What I do see is this pattern here, 04736F7274, which is the same as this here. And we know that this custom attribute for the Lisp export, if we go to qsort, we're exporting the function qsort with the name sort. So the export attribute will have the string sort as its argument. So that points to that specific byte sequence being the encoding in, like, this will be like a string table reference. So this is sort. Looks like there's some kind of null terminator. Then I think this is the length of the argument list. So this is the length of the argument list again. And then I think this must be the size. Yes, so the size, and this is where we were seeing FF before. But now we're seeing an actual size of 1, and then we're seeing the 1 value, which is a string table reference. So we can just validate that by, instead of looking at the IL, look at the decompiled code. And on our class declaration, we see that Lisp library has string array of sort, which is what we want. So that's one side of it. Now in the built-ins, we actually want to do the opposite. So at the moment, when it does try get signature from type, it picks the Lisp library attribute, gets the constructor arguments. So what this would have been a single string. But now what we want is we want to, this is going to be a custom attribute argument array. So I think yeah. It's a static coercion. How do you do a dynamic one? Can I just do as? Nope. Yes? Yes. Upcast. The downcast operators performs a dynamic cast. Colon. Question mark. And then that means that the args here is going to be a custom attribute argument array. So to turn that into a list, we're going to need to do seek dot. So it's going to be a seek dot map so we take each arg, and I think we can just do arg dot value dot to string. And then that needs to be of seek. And we should probably just wrap this a little bit so it's a bit nicer to look at. And with any luck, that means we should be able to get the example that I just showed before to compile again. So again, we're going to run the same compilation against libgreet for input test. And then still works, which is good. So let's commit. So we have the change in the built-in so that we're now finding the library name attribute array stuff. We've got the change in the compiler so that we emit an array of strings rather than just a single string. And we got the change to remove the constructor that we don't want. And then we can say fix library attribute in fix up attribute for library type classes. The thing about that, and the reason why it's important to be able to properly have a list rather than just pasting them together with a delimiter, is that there's actually nothing wrong with me defining a library if I do define library, I can call my library like $, and then I could do import test greeter begin export howdy begin. And then down here we could do import $. Whereas before, we wouldn't have been able to actually encode that library name properly because you wouldn't be able to tell the difference between the identifier $, and the identifier that we'd use to paste things together, which is always a problem when you use like delimiters. You need to make sure that the delimiter is not part of whatever you're trying to delimit. And the scheme is super permissive when it comes to what you can put into identifiers. I mean, we have some warnings about like things you probably shouldn't put into a library name. So that's in libraries, I believe. Yeah, when we pass the library, we have a list somewhere of all of the, these are the characters that Scheme says you probably shouldn't use in an identifier, but it doesn't say that you can't use them. It just means it's bad form. So like a backslash, you could have a backslash in a library name. You could have a question mark. Square brackets. The thing about square brackets is that lots of schemes treat square brackets and round brackets the same, just so that you can write code and understand the matching of your brackets a little bit better. So like if you'd have written that, then the compiler would have just treated it as exactly the same as the code I previously wrote, except for the fact that it kind of makes sure that the opening and closing square brackets and curly brackets match up. But that's an extension to the scheme specification. It's not something that's part of the standard. And it's not something that our compiler understands. Anyway, with that success, let's have a look at built-ins and how we pass out the signatures. So we have in the libraries we have this type called library signature, which has the name and a list of exports, which are basically just key value pairs. And in built-ins, we have these two methods: load referenced signatures and load core signatures. Well, load core signatures technically isn't actually a method because it's static. It's just a list. So load core signatures gets all of the core procedures and the core macros, groups them together by library name. So that allows us to split the definition of a library between multiple classes when we're doing core, whereas with the reference stuff, we just take everything from each type and put it into a single library signature. So in theory, you could end up with multiple library signatures with the same library name, but yeah, I don't know what we're doing about that. And then it builds up a library name and exports collection based on the second half of these. So each one of these core procedures and core macros returns a sequence or an enumerable where of pairs where the left is the name of the library and the right is all of the declarations. And then basically what this load core signatures is doing is just looping through, grouping them all by the library name, and then collecting together all of the bodies into a single big sequence. So it's flattening down a bunch of different library declarations. The interesting parts then for load reference signatures is that it uses this try get signature from type, which peeks at a type and returns an option. So it either finds the attribute and unpacks it as a library using option.map, or it returns none if the type isn't actually a library, which is entirely possible that some types or some things that you've referenced aren't things that contain scheme libraries, in which case we don't import them, we just don't provide you access to them. And for the core stuff, the way that the core procedures works is that we have this static reference to the core assembly, which we're just getting by doing type of .assembly. So we're using .NET reflection, whereas this bunch of code here that's used for loading the reference stuff is using monosessile style reflection. So the difference is that monosessile reflection is not actually loading it into your current app domain, so you can't create instances of the types and everything like that. If you look at the way that we're comparing each one of these, we're actually doing like attribute type.name equals. We're not actually able to say, is this an instance of Lisp export attribute? All we actually can do is say, does the type name match? And if it does, then it's probably the one that we care about. So this bit of code here is a bit weaker, and this bit here specifically is dubious, because we're just if the name matches, we're just delving straight into the first constructor argument's value, which I mean, it could be null, so it could throw. We could not have one, like it could be no arguments passed in, because it couldn't even be our attribute. We might have, yeah, there's loads of things wrong there. Hi, I do use Gurkha Jack says, do you use F# to build a web app or an API? I'm using F# to build a compiler. It's not really a web app, but it's a command line tool that we can use to convert scheme code into .NET binaries. At some point, it would be nice. Oh, have I ever used it to build a web app or API before? This is the only real thing I've ever used F# for. So, no. I've built web applications using .NET, but that's all C# and that kind of thing. Do you have questions about building web apps? Yeah, so monosessile stuff is just looking at the types. It's not actually loading them into your app domain, whereas core procedures is actually getting a reference to an assembly, which it's calling here find built-in methods. So find built-in methods is actually doing something similar to what it's doing something similar to what we do with the get exports. It's just that it's walking. This is walking through looking for the Lisp export attribute, whereas the find built-ins is doing, got the same like 2 level where it's finding the types and then it's finding them by this attribute. So find built-in methods for Thai gets all of the methods marked with the Lisp built-in attribute, and we map that over any type that's got the Lisp library attributes. So then we have there's this other slight wrinkle. So when we're compiling references to our libraries they've been compiled down to Scheme, we have like a dictionary of fields, and we use that to work out whether or not we should call import reference to add a reference from our assembly to the reference assembly to be able to load that field. And the way that the built-ins do it is that we have this separate method called load extern built-ins, which is the same thing. It calls find built-in methods on a given assembly and then calls import reference into some mono assembly. So this is adding metadata references from the mono assembly that we're compiling to types in some foreign assembly that we've got loaded through reflection. So it would be nice if we didn't have to deal with that. It would be nice if find built-in methods, load external built-ins, and load core types, which are all bringing things out of this assembly into the assembly that we're compiling. It'd be nice if all of that could just be done with mono style reflection, so that we didn't ever actually have to load the core assembly into our app domain, because that would then allow the compiler to cross-compile for different target frameworks. Goku Jack asks, do you know that F# is one of the top paying technologies? I don't know. No, I didn't. I don't tend to, well, I don't know. I'm not necessarily obsessed with specific languages because, if I use this language, then, I'll get paid more money. But I think there's a certain amount of languages that are in greater demand you would get paid more money for. So sometimes that's because the languages are more obscure or they're newer, or sometimes it's because they're older and on their way out. So quite a lot of the time you get paid more money to maintain like really old legacy software. So if you know some of the programming languages that get used on really old mainframes and things, then banks and those kind of institutions that can't really afford to port, not from they don't have the money, but they can't tolerate the risk, will end up just instead paying lots of money for a small group of people to continue to support old technologies. Yeah, Stack Overflow Sophie. But it's interesting because I noticed that, didn't that one find out that people who indent with spaces get paid more money than people who indent with tabs and stuff like that? So I think there's a certain amount of spurious correlation that can happen as well. So it could just be that higher paid developers tend to use F# rather than people who develop in F# tend to be paid more money. I don't know which way around the whole thing would go. It's interesting. There's definitely not that many things that are written in F#. And having given it a go, I don't know why. Like, I know that back when, a long time ago, I was working with some infrastructure that was provisioned with vSphere, I think, and the VMware vSphere management UI was written in F#, and that was like a big thing. It's like, oh, did you know that the UI is written in F#? I was like, well, I mean, like it looks the same and it works the same, but yeah. I've not really heard of that many things. Like I know the F# compiler is written in F#, but I've not really heard of many things that are. So back to find built-ins. So we've got find built-ins, load external, which is the stuff where we're importing it into the namespace. I think we can probably initially just convert find built-in methods over to using a mono assembly instead of a proper system reflection assembly. So that would mean changing core procedures. How many places call this Serhefa assembly? We've got the definition, we've got the find built-in method call that we knew about, we've got import core, which is what does that load external built-ins. So this is, so import core, this is the thing that gets called from compile. And it returns an instance of this core types, I think. So yeah, I think the first thing we could probably do is switch load external. We can switch over core procedures to load it in via mono. And then go from there, I guess, and just slowly weed out all of the direct references to this until we can eventually just delete this property. And have it so that maybe we want it so that the compiler passes in the reference path, because it might be nice to support being able to say like -- core - assembly or something on the command line and then have it default to something if we can't find it. F# is number 11 on the most loved languages and C# is number 12. Well, I mean, the thing is, I do like both of them. Where's Rust on that list? That's the question. I think every language. Well, no, that's actually probably. I was going to start on a horrendous generalization to say that every language has its merits. Some languages probably don't have their merits. I mean, I was going to make a joke about Perl there, but I mean, the fact is that you can write software in Perl and it can be useful. So, could make a joke about brainfuck, but the thing is that it's quite a nice, simple language actually, and writing a compiler for it can be an interesting way to learn about how compilers work and how you can optimize code. So, yeah. If you do think of one that's absolute trash and that you should definitely never use, then shout out. Oh, I guess PHP. Yeah, we can dislike PHP. Although I haven't used it in probably like 15 years now. You're looking forward to being an F# developer too. You're currently a C# developer. I mean, you should do. It's great. it'd be even better if I got paid money to do it. I think just working in more than one paradigm, working in more than one language is just generally good as a developer, because you gain experience of different ways of tackling problems, and so tools and techniques from one language can influence the decisions that you make in implementing stuff in another one. Language wars at the end of the day are just pointless, and it's basically just a popularity contest, which just never ends well. The main problem there is that you say like, oh, it's merit, it's driven by merit or whatever, but it isn't. Some of the reason why things like C# and F# are popular, like TypeScript, is because they have big companies behind them. So like goes an acceptable language, but the reason why it's so popular is just because Google can throw all of the money at it. Jack says, I'd like to know how functional programming works and how to think and solve problems using it. Yeah, that's the thing. It's like thinking in terms of functions is different, and it can definitely influence the way you go about solving problems. We went over that a bit yesterday. We were discussing the fib. So this was the implementation of the Fibonacci algorithm that we came up with, where and I was comparing and contrasting that to how you might write it in C#, where you might do, I'm going to have to remember it all again. So like int cur next. We started them both off at 1. And then we did like while n, what was for int I equals 0, I is less than n, a plus plus. So just a standard for loop. And then we said we said last, I think, here. Cur equals next plus last. Then it's just last equals next equals cur. Return next, something like that. Anyway, let's just comment that all out so that. And how this is effectively like doing a loop, and we've got the two variables, and you're doing this in a very imperative programming while oh, you were there, yeah. And then like it's comparing it to how like you can definitely see the similarities, like the 1 and the 1 is the 1 and 1 that are initializing that. Yeah. Back on target. Built-ins. Core procedures. So instead of passing in the whole assembly, let's just pass in the full name. No. Path. What do we want to pass in? Location. Yeah, that sounds about right. Then we can have find built-in methods. Instead of taking an assembly, it can take a string. And then we can do assembly that's really... We do like assembly reference load this thing. Well, let's copy the whole body of this and just like smash these two together and see what ends up coming out. So we load the assembly. We can still keep our find built-ins blah for meth. Okay, still keep that. I can make that try find. We've got like 2 levels of mapping going on here. I'm trying to work out what we want. So this was returning just a single thing, so was it? Or was it returning a list? It must have been because we're doing seek.choose, so it must have been returning some kind of list. It's going through and finding all of the libraries. So that's shared code with this. Try get signature from type. So let's just move all of this up to the top so that we can see it all together. Get exported items from given mono type definition. Try to convert a given type So only expected to produce a library signature storage ref list. So I think we can do this. So find built-in methods. Is that's saying it's a type? I'm gonna not touch that until I've fixed up this up the top. what we want is that we want get exports maybe. If we had get exports support the Lisp built-in attribute as well. So that's producing an optional storage wrap. Can we do option dot, well, or else? I mean, we could try doing it with some optional else chaining, but I'm also tempted to just do it straight in here with the if else. So can I do elif if we have the Lisp built-in attribute? Same thing, we're picking out the constructor argument. And then instead of using this option map to turn it into a pair with the external name and that kind of thing, we can do let name equals that. And we need to return some name and then this global Thai full name field name. So we can get rid of that map and then we are missing something. Yeah. Then what we need is, how is this? We were building a built-in from that, which I think is somewhere down here. Yeah. So again, it is, so we've got the attribute and the export. So it just says storage ref built-in a.name. So I think all we're doing here is doing let name equals, and then that same thing to get the constructor argument, and then we are returning name built-in name like that. And then that's a sequence storage ref list. And then try get signature from type is going to return a signature that includes built-ins and exports. So then I don't think we need any find built-in methods. Because load extern built-ins can call yeah, that's not worked quite. Because we've not actually got the methods anymore. That'll at least make it compile for the time being. But it's this bit down here where we would have we made core macros return an actual library signature. We're going to get rid of core procedures and have this is library name and then exports. And what's wrong here? So it's taking the macros. It needs to be list.map because we actually want the list at the end. So that's then producing library signatures for the core macros, and then that means we can core procedures can be load referenced signatures location. Then we can group by the group by library name. Core macros doesn't have a type definition. Try to get a signature from type. Return the type. That's awkward. We don't actually have. We don't have a type for any of those macros. Maybe we do need like a load core methods again, which is going to do what is it going to do? Let's private core methods. It's going to do load referenced signatures. From there. Discard the type. Return the signatures. We can make that this in here. So we'll group them by the library name, and then collecting the exports. No. Go back to parts because this is a sequence of libraries. Then the collect wants to discard the name and take the body exports. Expecting a library signature list, but given a library signature object list. So bodies is a sequence of string object y. So parts is a sequence of library signatures. And that is a library signature object for some reason. Type pair something and library signature something else does not match the types. It says, by the time it gets to here, it's a sequence of lists, of a sequence of pairs of lists and sequences of storage refs. So this should map, that should be a list. This is a sequence of storage ref, right? So parts seek.map that's then so why is if a library signature storage ref, why is the definition, why is that type not carrying through? So P is a library signature of storage ref, but P exports is a list of string something. Okay, so now it thinks sequence collect. Oh, that needs to be concat. Okay. List of seek. And then this is saying I can now do collect that. I don't understand why that works and the other one didn't. Countron says, hi there. Hello. The red squiggly's disappeared. So let's run that. And we expect stuff not to work. Because, amongst other things, we commented out a huge bunch of code, which is probably important code. Yeah, look at all that failure. Could you use a flat map instead of the concat? Maybe. Which concat? Because there's a few of them. Do you mean the one here? That's a collect. Concat. I think I must have refactored away the concat. So what we need to fix up now is the fact that load extern built-ins is yeah, we don't have a great way of continuing to do this import reference stuff. Now, we do have a similar problem with adding references to externs as well. So I wonder if we could get import core to do both of those things at the same time. But at the moment, it's passing in the assembly. So if you made load core types capable of getting the core types out of a sequence of mono assembly references and load extern built-ins capable of doing the same thing, what it can do with is, where do we call import core from? One place. So we have Reflebs. We get the externs. So that's allowing us to pick the fields off the types. We got the initializers for the libraries as well, which is a bit of a hack. Let's move that code into built-ins then, at least. So we'd have built-ins take whatever reflebs is. So both of them, it just takes the sequence of type definitions. I think that's a sequence of type definitions and library signatures. It is. But it doesn't include our core signature. Starting to feel like it would be a bigger refactor. So it needs a method reference. How about try get signature from type? Is mapping try get signature from type is mapping a given function over all of the public parts. I'm wondering if we could make this a little bit more parameterized and pass in a function, pass in this function to do the mapping. I guess other option is we could have get exports, take some functions that we use to map over and use to construct the globals and built-ins. We could also, like, we have the method reference. Oh, I see. This isn't even going to work because we need this to be like let exports. We need to collect the exports like this. Do the same thing for the built-ins because built-ins are actually methods. So that's going to be tied up methods. And then we can do seek.concat. Something's really not happy here. Value is not a function. Oh yeah, let's see seek.append. Seek.append. So then this is going to be if it is a built-in, and this is going to be if it is an export. Doesn't really gain us anything though, I don't think. Close and reopen just in case that causes it to... Yes, syntax highlighting is back in the game. So that is actually a method. So here we could potentially... Yeah, we could potentially have a method reference in there, but I'd like this to remain like a... I mean, it's got macros in there, but yeah, maybe... Oh my god, let's make it of method reference. Where am I going with this? Here. Would this work? So then this would be a built-in fun method. We can get rid of load core. Sorry, load extern build. Well, I can still leave it there as Then in the compiler, we'll need to deal with built-ins. So load store or emit load, something like that. So load from. Give up. So we got write to and read from. So built in, and that's now going to be a method. So then we can do context dot assembly import reference method instead. Like that. This might work. If it does, it needs a little bit of cleaning up. Wow, it does not. Lower is not happy. That's broken things because it's meant that storage ref can't be compared anymore. Back it out. So core methods. What do we do? Yeah, that wants to be. Let's see. If we try and rewrite this. So we take on global and on built-in. And here we do on global name field, I guess. And here we take name and method. And we take the type definition last here. That needs to be on built-in like that. What are you unhappy about? Expected to have type string. Field dot type. I mean, we could just We could just pass the type in as well, I guess. So then instead of doing, so try get signature from type would be something like, we'll do like walk type or kata. We've got kata exports. And then it's going to take an on method. So on, what do we call them up here? On global, on built-in. Maybe it wants just a function to run over to produce the exports. Yeah, it probably just wants this thing down here. If we do this as like try type. Not quite happy. Counter says fold over the method, over the fields. I think you should be able to merge both the mapping functions for methods and fields. Or at least try pick. You're probably right. I'll try and get this bit compiling again first, though. And let's get expected tie. Okay. Takes a string and a method definition. Okay. That needs some brackets around it. Incomplete structured construct. Everything goes wrong starting here. So we got an array of custom attribute arguments. I'm clearly missing a bracket or indentation or something. So this is taking a type definition. It's taking a function that takes a type definition, a custom attribute arguments, and returns something, and a type definition, and produces an optionally that something. It's because this is the one that's unterminated. Okay, so name is expecting string list. Yeah, we can do that. That just wants to be the seek dot map. Then down here we can do I think we're still going to have to do a little bit of hackery because we're going to have to load the assembly again. it's going to be extern assembly dot location, and then we take the types and we map them with seek dot map for the time being. And we want to do try cata type, and on lib is going to be cata exports, and the on global is going to be a function that takes two things and returns none. And then this one is going to be something that takes the name and the method and returns some method. Now where are we at? We've now got a sequence of options, and then I think so. Type this episode about that. So cat exports on global and built-in. On global, needs to be something takes 3 arguments, returns none. Then the second one needs to be something that takes 2 arguments, which ours does. Then I think if we do, what is that going to be doing? Still complaining. Some of it's because the type is discarded. I think we need another. This is what we need. It's a sequence of lists of method definitions now. So if we take that, map it through that, we end up with a list, and then can we do list choose? Yeah, if we just do list.choose with the identity function. I think from all the try picks, you could extract the constructor bit, this bit, into a map and create either a function that gets the string of a value and return the process value or none if the string is not what was expected. I think that the key thing here, though, is that we're mapping over the fields here and we're mapping over the methods here. We only care about it. We only care about doing this bit when we found an attribute. It could probably have a helper function that takes an attribute and returns the string constructor argument, and another one that returns the string array. And you could probably have but I'm just trying to get back to a state where it even roughly compiles. So that's then a method definition list. And then if we do seek dot map, let's concat it all first. Then we take the method declaration and we turn it into this wants to be a pair, doesn't it? Because otherwise we've lost the name. That's going to be ID and method, and we do ID and Lisp assembly main module import reference M. Oh, that's nasty. We need to upcast that to a method reference. Expecting a sequence of so what on earth that type? So that's a sequence of pairs where the left is a function that takes an object and returns a method definition. Because that's okay, right. Because that's the identity function, I think. Is that better? And this is actually a pair. That better? Yes. Jason Oberg, hello. F# is a functional programming language. It is based on, is it ML? And it compiles down to .NET. Well, that built more tests appear to be passing. What's the one failure? Fib. Oh. We changed it, so it all passes differently. It's not really our fault. I mean, it's my fault, definitely. So yeah, that's not necessarily better, but we can at least make this load happen outside. Import method references for any built-ins in there. In the external assembly. Let's fix up that call site. So we want to do that. This needs to be extern assembly main module types. Yeah, hopefully this won't stay around for too long, so I don't want to refactor it too much. I'd rather just bin it. Maybe map a given type if it do for now. That doesn't really need to be a list. On built-in or this built-in. Somewhere is probably broken because I got rid of, yeah, so get exports list of seek, which could also be done here. No, it couldn't. Could it? Yes. Now we don't end up with the unnecessary collection into a list partway through. If it still compiles, it still runs, I think we'll stage that. What have we actually changed though? I mean, the goal here was to unify the way that we access built-ins and libraries. No, that's not happy. A lot of failures there, which is hopefully should be fairly easy to identify. Get instances declared in another module needs to be imported. Okay. Why is that not happening anymore? Load core types not being called. Was being called, but with the wrong target assembly. Fingers crossed. Then what have we got? Import test. I mean, yeah. Let's just back that out because we don't need that. And then the change has all been in built-ins. 58. That's still not good. Something's still not quite right in that refactor down here. Oh yeah, load external built-ins core assembly. It's just loading the references back into itself. I did a bad rename, didn't I? Now it must surely work. So yeah, we've got the function with the trypix, which Cantron thinks we should be able to refactor, but I can't see it. We've got a switch to have core macros return a library signature. I can see a bunch of tests failing at the bottom. And then we've got the change so that we actually load the reference signatures. We from the core library using the same mono-based reflection rather than what we were doing before with direct.net reflection. I mean, I can see the problem yet again. So let's just make 100% sure. So core assembly here is our version. Let's just call it what it is. Let's just use aliasing, right? And then everywhere that's red needs to be fixed. So we're loading the external built-ins from Serhefa into the target assembly. Then we're loading the core types. Yeah. In the mono reference, we're loading that using .NET reflection. Then we're adding the environment declarations to the target assembly. So that must mean 12 things actually used the captures, which is probably lower than I was expecting. Cool. Right, I'm happy with that. I'm going to stage it and commit it. Use mono reflection core type load. Switch from .NET. To walking the mono Cecil type of graph when loading built-ins. There's still more refactoring. Oh, no, not bind. So what can we do here? Well, I guess the first thing we could do is we can extract this bit out. So let's do, it's going to be unpack string arg. And it's going to take an attribute and it's going to do this attribute constructor blah to string. And then instead of name, we can do unpack string arg at and that's going to be custom attribute. Wow, what is it? Yeah, I think it's custom attribute. We can do the same thing down here. And then this bit is the same for both. So this is a function which going to map some function map with matching or something. Choose matching. And it's got given a name. It's going to be given a callback matching, and it's going to be given a list of, or sequence of something. And what it's going to do is things. It's going to do seek.choose fun thing. Let's go thing.custom attributes. Try pick. If the attribute matches, then we do sum. And then I think this is going to be on matching thing. I think we'll do unpack arg as well. Then we'll just refactor it so that on global takes the thing, takes its arguments in a different order. Else none. What are you upset about? If then exports is fields mapped to choose matching export attribute, and then we'll do on global tie Then we've got some red here. What is wrong? That. Yeah, objective indeterminate type. this I think needs to be I have custom attributes. There's a type for it in monocessal. I custom attribute provider, I think it is. Nope. Why? Why not? Look, I custom attribute provider has a custom attributes on it. It's right there. Oh, it's because I spelled it wrong. Fair enough. And then it's close. It's close to working. The problem is, if we went through and casted it, then on built-in isn't going to get a method reference anymore. So I think this needs to be, like, choose matching needs to be generic. Can you put constraints? On methods. I'm doing fields 2 times. It doesn't matter for the thing that I'm running into. You're right, though. So I think the first thing I can do is at least I can make it so that type name comes first. The problem here, though, is that if we cast this, then on built-in we'll be getting yeah. The unbuilt-in would be getting the wrong type. Can I make it generic? Can I do like that? Is that how you do it? On module member bindings. Well, that's unfortunate. Is a sequence of a well, that's a mess. Unexpected keyboard, yeah. Does that need to be like a sequence of A when A is custom attribute provider like that? Maybe? Maybe more brackets helps? No. That's kind of working. What I want is, I want it to be generic so that I can pass in either of the things that support custom attribute providers. I'm just having a look at the F# docs over here and it's not the most obvious about type constraints. So most of them are class-based ones, but it says like type must be equal to or derived from the type specified. I mean, is that what I want? If that works, that is, it's surely something's got to break. Control says just use seek I custom attribute, but the problem is if I do a sequence of custom attributes, then this will work. But when we do the try pick here, we call unmatching thing, which would then be typed as I custom attribute provider. But the methods that we pass in here expect, well, this one doesn't care, but the other ones where we do load external built-ins, we care that it's a method reference. So we don't want to lose sight of the thing, the type that we're matching, because here we're doing it over fields. We want that to still be field definition. So then choose matching. That works. Refactor. What exactly is it? Guess that'll do. And you were saying earlier about being able to call unpack. So being able to do this bit, build up a map. I suppose. Like for each type, you'd be able to for each field or for each method, you'd be able to turn the custom attributes into a dictionary indexed by name and then pick them out of there if it did match. But that seems a bit over the top because you end up building a dictionary that you don't need. At least the way that I can see being able to doing it, you would. I'm more happy with what we've got there, though. We'll check that off. And then that leaves one last thing to do. T supplies are running low. So I'm going to try and make this fast. We currently have spec folder. So, and we have an example which requires being having something else compiled before it. So what I think we should do is move this into the spec folder, see how it fails, and then fix it. So if I run the test now, we should end up with two failures. One because it's failing to parse, and one because it's failing to compile. Because to be able to compile it, we need to have that library. So one because it's failing to parse, and the other one because it's failing to compile. We can fix the failing to parse one trivially, but we're going to meddle with things in the future, so I'm not going to fix that one yet, because otherwise I'll just be updating the snapshots all the time. And then this reference to undefined symbol and could not find library test greeter. I mean, we could just generate snapshots and then be done with it, but that's not actually testing the problem. So we want to go to the spec tests, list specs, goes through a spec directory and looks for everything that's SCM. So what does libgreet do? Yeah. Let's change what import test does. So instead of doing test greeter, we will import example display utils, and then we will do something like display all, and then library reference test, and we'll list it all up for the time being because that's going to make it easier. So we need to implement display utils. So new file display. What I'm going to do is we have SCM for scheme files. There's SS for scheme scripts and S. I've just forgotten the extension. What is the scheme file extension? SLD for scheme library definition. Come on, we don't want that to be an assembly file. Scheme library definition. Then in here we can do define. Well, let's just go and copy what we had in greet. And we get rid of this and this, and we just have the it doesn't support change language scheme And then we got import test is expecting example display utils. And it's expecting to import display all. And then it's expecting display all things to basically be equal, or if null things display, new line, otherwise begin display car things, display all header things. So we just recurse down the tree. And then in the spec tests, we can so run example. No, we don't want to do anything to that. It's going to be with compile file. Compile file exe path source path. So the key here is going to be that references needs to be made up of all of the SLD. Right, I'm going to do a little bit of a hack here. So we will say import test. And then in spec tests, we will say when we want to run it, we take the source path and then we say if lib or backing lib path equals path dot change extension source path SLD. Then we can do if file that exists backing lib path we'll build up a references list. So what we want to do here is library options is going to be the same kind of thing as the executable ones, but the output type is going to be lib. And the references is going to be empty. And then we can do compile file. S That's not going to work. We need to use get file name. Lib path, lib options, output type, and then we can do match compile file lib options lib path backing lib if we got any diagnostics, then we'll do fail with this compilation error backing library, and then anything else this is the right way around. We're going to fail if there was anything else, and if there wasn't, then we can return a list containing libpath, I think. So we create a library source path based on the test source path. Let's do run task, update snapshots, and see what we end up with. Given that I'm changing how we compile those specs, I wouldn't be surprised if a fair number have changed. Right, what are you complaining about? Import test. Compilation error, reference to undefined symbol display or could not find library display utils. Okay, so you're still failing with that same problem. It's just because I've misspelt the name. What a totally not surprising. So if we just use copy and paste, then there we go. Now, how about now? Is it the same error? We still got one failure. Compilation error in backing library location, missing closing. Okay. I mean, there is. It's not wrong. What now? Import test dot pdb because it is being used by another process. Yes. Well, see, the thing about making all of their library names match up is that all the library names match up. So now hopefully we should end up with the library being compiled to like import test backing.dll and backing.pdb so that no one is using those file paths. Nope. What now? It's in compile file from here. Let's just do that. I mean, the path, that is what we're using as a reference. What are we globbing for? We are doing SCM, so we shouldn't be compiling the backing library in parallel. I mean, there's a certain argument that we should just make sure that we close that stream. So how about we do symbols dot option dot map close. Can't quite understand why that file is still open though, because hopefully we should be generating unique names for all these. Import test. Cannot access the file. Import test.sld backing.dll. Ooh. We're getting closer. The problem is that because we were leaking this file handles, we hadn't finished writing the executable, and therefore the next compilation process couldn't read the files in to be able to reference the library. Boom. Kind of works. And let's have a look at what we've got in the output directory. So we have, hopefully, now this is the thing, it's like we've got import test SLD backing runtime config. We probably shouldn't have that file. I think if diags is empty and is and a function, oh, okay. Is it that? Yep, Boolean and is something like that. So if diagnostics are empty and options dot output type is output type .exe. So it's just spec bin. Run the test task again and then see what we end up with. No spec bin yet. So I think we want to get the one last thing that would be nice would be if we did get file name without extension. So we That's not happy bash window. Spec bin. And then if we do the test task again. We now are ending up with import test. That's the import test we care about, and import test backing and PDB. So we're getting the symbols, but we're not getting the runtime config when we're compiling the backing library, which is good because it's not supposed to be executable. So the test task all worked. I think that's it. So let's go through and compile this. So stage this. What have we changed? So we've got the change to import test. We've got the change to properly close. We should put a comment there. Close the streams. Now we have finished writing the compilation output. We got the change to spec tests to allow us to have a backing library. We've got the parsing for the import test. And we've got the output for the library reference test. Add library reference test. This we can compile file and reference it. Right, that's it. So thanks for watching. Unless you've got any more questions, I think it's time. Thanks, everyone.